Now, we will going to take up one more problem on projections of line, problem number 46. A line capital AB, 65 mm long, has its end capital A, 20 mm above HP and 25 mm in front of VP. The end capital B is 40 mm above HP and 60 mm in front of VP. Draw the projections of capital AB and show its inclinations with HP and VP. This is some similar, exactly the similar way of doing this problem, except that the dimensions have been changed. Here, he has given a line capital AB 65 mm long. So that means he has given the true length, has its end capital A 20 mm above HP and 25 mm in front of VP. So he has given the end A, position of end A, and the end B is 40 mm above HP and 60 mm in front of VP. So he has given the locus of B also, both in the front view and as well as in the top view. Draw the projections of capital AB and show its inclinations with HP and VP. So we need to find out the front view and top view and its inclinations. So, and also true length and also true inclinations and true inclination with respect to HP and VP, and apparent length with respect to apparent inclinations with respect to HP and VP. So now we will try to analyze this problem now. So here he says end capital A is 20 mm above HP and 25 mm in front of VP. So when you look from the front view, we can see the distance end A, which is above HP by 20 mm. So that image will going to fall on the vertical plane. So we can see that this distance is A dash, and you mark this point as A dash and capital A. Similarly, when you look from the top view, we can see the distance in front of VP, which is 25 mm. So the end A is in front of VP by 25 mm. When you look from the top view, that image will going to fall on the horizontal plane, and you mark this point as small a and also as capital A. As we go for the other end point, NB is 40 mm above HP. So you can see this distance is NB, which is 40 mm above HP. So when you look from the front view, so that image will going to fall on the vertical plane, so which is 40 mm above HP, and then you write the locus of B in the front view. Similarly, when you look from the top view, we can see the distance in front of VP by 60 mm. So we will going to get this distance as in front of VP. So that in front of VP, when you look from the top view, we can see the distance here. So it is in front of VP by 60 mm, and write this as the locus of B in the top view. Now we need to find the true length, which we need to identify the true length here, which is 65 mm. So here, first, you know NDA and you know the locus of B. You take 65 mm and you mark this on locus of B, so you're going to get as capital AB1. So that means, so here you will going to get this line as AB1, wherein you have the length, you will be able to have 65 mm. So when you look from the front view, that image will going to fall on the vertical plane. So you will going to get this as the true length line, which is 65 mm. So once you get this 65 mm, so you will going to get the angle theta. So we know that this is the true length in the vertical plane. Why? Because when you look from the top view, both capital A, B1 is in front of VP by 20 mm. This is the line in space. When you look from the front view, so you will going to get that line in on the vertical plane. Similarly, when you look from the top view, we can see this length will going to be the true length, which is in the top view, which is AB2, capital AB2. So here, because we know that NDA is above HP by 20 mm and B also above HP by 20 mm. So this line, A capital AB2, is the line which is having a length of 65, will be in true length. So naturally, so when you look from the top view, we can see that image on the horizontal plane, which is capital AB2, which is will go to 65 mm. So now we need to analyze this to find out what is the front view and the top view now. So to find out the top view, so we have to take the initial position of the true length in the front view. So what is the true length in the front view? Capital AB1 is the line which will be the true length in the front view. With A as center, taking the radius of AB1, you rotate that line in space. When you are rotating such that B1 will going to see here, that image is B1 in the top view. When you start rotating in space, also that image will also start rotating such that the B1 will come and touches the locus of B in the top view. So you will going to get this point B. So that means when it is projected, you will going to get this point capital B here. So this is the line in space which you will going to have AB. So now So this distance is small AB. So the inclination made by this with respect to VP is called beta. So similarly, if you now we want to find the front view and its inclination, so we need to take the top view true length. Which is the top view true length? Capital AB2. So when you look from the front view, so A dash is above HP by 20 mm and B2 dash is also above HP by 20 mm. Therefore, that line is parallel to HP. Since it is parallel to HP, so we are getting the true length in HP. So what we are doing now, we are rotating this capital AB2 such that when you are rotating this, you observe here what happens. When you are rotating capital with A as center, taking the radius of AB2, we are rotating. So automatically, so now here, this is the image. So once you start rotating in space, automatically this will also start rotating on the vertical plane. So till where it will going to rotate? Till it is going to cut the locus of B in the front view. So that means you will going to get this point B dash. So here this is the capital B. So this is how you will be able to get this B dash. Then once you get A dash B dash, then you join A dash B dash with a dark line because this capital AB is joined together. So this is how you will be able to analyze this problem. So first we will go for the individual stepwise now. So to do that, so first we will go to this. So first we have the true length in the front view and also the true length in the top view. Now we need to find out the top view and its inclination. So first we are going to take the true length in the front view. We know that this is the line which is the true length in the front view because its top view line is parallel. So when you look from the top view, we can see that AB1 is parallel to VP. So you are getting the true length in VP. So when it is projected, you will going to get this as A dash B1 dash. So I need to find the top view now. So actually B1 is not in front of VP by 25 mm, but it is in front of VP by 60 mm. Therefore, with A as center, taking the radius of AB1, you are rotating this line in space. So what happens in the image? So that image is also starts rotating till where it will going to rotate till it cuts the locus of B in the top view. So once you get this point B, so this is the point where you will go to get B. So this will going to be small AB. So that is what we have shown here. We have taken the true length in the front view. So obviously in the top view, that line should be parallel to XY. Therefore, AB1 is parallel to XY line. So, but due to the presence of locus of B here, which is 60 mm in front of VP, with A as center, taking the radius of AB1, you are rotating such that it will going to cut the locus of B in the top view. So, you will going to get this as AB. So, join AB with a dark line. So, you know, now this will going to be the inclination, which will going to be apparent inclination with respect to VP. So, that is what we have shown here. Similarly, when you are taking the front view and its inclination, so we need to take the top view now. So where is the top view? The top view is here. So here capital AB2 is the true length in the top view. Obviously it should be parallel to XY line in the front view. So when you look from the front view, both A and B2 are above HP by 20 mm. Therefore, when it is projected, A dash B2 dash is parallel to XY line. So that is both A dash and B2 dash is above HP by 20 mm. So once you rotate here, so here as we rotate, where it will go, so B2 dash is not in front of above HP by 20 mm. Instead, it is above HP by 40 mm. So with A dash as center, taking the radius of A dash B2 dash, in other words, you are rotating capital AB2 with A as center, AB2 as the radius, you are rotating such that B will going to cut the locus of B in the front view. So once it is projected, you are going to get this B dash. So that means the B will be rotated till it is above HP by 40 mm. So when it is projected, you will going to get it on the locus of B. So therefore, you will going to get A dash B dash. So the inclination made, apparent inclination made by this with respect to HP is called alpha. So how do we see from orthographic view? So here we have the top view true length. So we know that this is the top view true length because it is given in the problem. So you have capital A and you have capital B. So this is the true length in HP because it is parallel to XY line in the front view. So you can see here A dash B2 dash is parallel to XY. Therefore, its corresponding top view will be in true length. So you have AB2 is in true length. So, but actually the B2 dash is not above HP by 20 mm. It is instead, it is above HP by 40 mm. Therefore, with A dash as center, taking the radius of A dash B2 dash, you rotate because the length of the line should not alter. Suppose if you just project this and take this point here B2 dash, then you just draw a line B dash. So it is not the top view. That is because A dash B dash and this A dash B dash will not be equal. So we need to rotate so that the length of the front view should not alter. Therefore, A dash B2 dash will have equal to A dash B dash. So the true apparent inclination with respect to theta is called alpha. So measure this value of angle alpha. So this is how you will be able to analyze individually. Now we will go to how to solve this problem using manually. So first we will going to draw the XY line and you mark VP and HP as shown. So from this, by using the scale, you measure the length of 20 mm above XY line, and from here you take 25 mm below XY line and you draw the horizontal lines and consider any point and draw a vertical line, and you mark this point as A dash and this as A and this as capital A and this as capital B. Similarly, from XY line, you measure 40 mm above XY line, you draw a dash dot line. Similarly, from XY line, you measure 60 mm below XY line and draw a dash dot line. So then you write the locus of B here and then you write the locus of B. As he has given the true length, which is 65 mm, by using the compass with A dash as center, take a radius of 65 and cut an arc on the locus of B and mark this point as B1 dash because that is the one first you are considering. So that is the reason why you are going to get it as B1 dash. So you mark this as capital B and this as B1 dash. And then join A dash B1 dash with little bit thicker than the XY line. Similarly, with A as center, take the radius of 65 and cut an arc on the locus of B and you mark this point as B2 and capital B. Then join A B2 with little bit thicker than the XY line. So now we need to find out the top view and its inclination. So you take the front view true length. So we know that A dash B1 dash is the true length in the front view because its corresponding top view will be parallel to XY. So A is in front of VP by 25 mm. B1 should also be in front of VP by 25 mm. Therefore, from B1 dash, you draw a vertical projector, tilt to the locus of locus of A in the front view, the top view, and you mark this point as B1 and join AB1 with in line. So with A as center, taking the radius of AB1, you draw an arc by using the compass, till cuts the locus of B in the top view, and you mark this point as small b, then join A to B with a dark line. So you measure this angle beta by using the protractor, and you measure this angle phi by using the protractor. Beta will be equal to 34 degree and phi will be equal to 33 degrees. Similarly, you take the with B2, draw a vertical projector from B2 to the front view, tilt to the locus of A in the front view. So you're going to get this B2 dash because the top view true length is AB2. Its corresponding front view will be parallel to XY. So A dash B2 dash is the one. This line is parallel to XY. Therefore, AB2 is in true length. So with A dash as center, taking the radius of A dash B2 dash, because B2 dash should be above XY line by 40 mm. It is only 20 mm above XY line here. So with A dash as center, taking the radius of A dash B2 dash, you draw an arc such that it will going to cut the locus of B in the front view, and you mark this point as B dash, and then join A dash B dash with a dark line and mark this angle as theta and alpha. By using the protractor, you measure the true inclination with respect to HP, which is theta 18 degrees, and true apparent inclination with respect to HP alpha, which will be 21 degrees. So show the dimensions, and this is how you will be able to solve the problem manually and analyze and solve this problem manually by using the sketchbook. Thank you.